Problem 10.1, using the cube at right as a model, work with your team to create two problem situations that would require knowing the surface area of the cube. Then make another two problem situations that would require knowing the volume of the cube. All right, so you can see that we have this drawing of a cube here that they give us. It's 3 feet wide by 3 feet long by 3 feet high. Okay, so all of the sides are the same length because it is a cube. So we need to figure out basically what this question is asking us is, hey, come up with two scenarios where we would want to find the surface area of the cube. All right, so why would we want to find the surface area of this cube? Let's come up with some scenarios. And also, why would we want to know the volume of the cube? All right, so first of all, let's talk surface area. So surface area is the area of all of the sides on the cube. So how many sides do we have on a cube? We have 6 sides. So why would we need to know the surface area? What would 2 reasons be? And then the volume, of course, is going to be how much can we fit inside of this cube. So let's start with surface area. Let's pretend that we have this cube here, and let's say that this cube happens to be a box, a perfectly cube-shaped box. And we could say that there's maybe some sort of birthday gift in the box. So one reason we might want to know about the surface area is so we can know how much wrapping paper we would need to use on it, right? Because wrapping paper would be covering the entire outside of this cube. So we can write that down as our first example. So we'll say maybe covering the cube in wrapping paper. All right, again, because, in this situation, we could pretend like it is a birthday present that is in a cube-shaped box. And second of all, why would we want to know the surface area of the cube? Well, another situation where we might be interested in the surface area of the cube is if we want to, again, cover it in something else. So let's say we were going to paint the cube. For whatever reason, maybe it's part of an art project or some sort of project. For whatever reason, we want to paint it. So we would need to know the surface area. So let's also say painting the cube. Because again, that would require us to go around the entire outside, all 6 surfaces of that cube. All right, volume now. Remember, volume is going to be how much can we fit inside of this. So let's say we have our cube here that's 3 feet by 3 feet by 3 feet. So maybe we want to fill this cube with maybe concrete. Maybe it's going to be something for construction. So we could say filling the cube with concrete and again, maybe for construction purposes. Or we could be filling it with water. We could be filling it with sand, but I just can't think of a good reason to fill a 3 foot by 3 foot by 3 foot cube with water or sand. So For my second, now if you can come up with a great idea, that's good. And you could even say fill it with water, fill it with sand. I'm going to say, let's fill it with dirt. And we'll just say for gardening purposes. 3 feet's a lot though. 3 feet tall or 3 feet deep for a garden. But you get the picture here. So surface area, what we're thinking about or what we are dealing with when it comes to surface area is we are looking at the outside. So all of the 6 faces of the cube. So how much area is on all of the outside of the cube? So remember, a cube is 3-dimensional. Volume, we are dealing with how much can we fit into the cube, whether it's water, whether it's sand, whether it's concrete, whether it's dirt, how much will the cube hold? All right, and this is all for 10-1.